Hi, welcome to this recording. This recording is tailored to explain the content of concentrations of medicines and also provide help with graphing and help you to start with your concentration of medicine assignment. Alright, so before I start, I would like to make sure you know where to get the content. So to get the content, let us take a look. You go to your course home, okay? Here's our new course home page. Not new course, I added some stuff. To get to the content, you can scroll all the way down to the bottom where you see Content Browser. And here, you can click on each and every module to learn the material. You can also get the course content under Course Materials, Content. Once you click on that, it will pull out a table of contents, and this module is located under Reasoning Using Mathematical Model. Once you click on that, it will open up a browser, and this is where you learn your material for this course. Make sure you go through each page and also the handout. If there is an interactive activity, make sure you do them. Click this button to go to each and every page. Today we are going to discuss the specific of page 7 under Reasoning Using Mathematical Models. We will discuss the step-by-step how they get the answer of concentrations of medicine. I took all the content under this section and I broke it down here, and I will show you how to do the graph. Here's the scenario. Have you ever taken a medication that your doctor warned you would not take effect for a few days? In this activity, we will investigate why this is the case. Consider the allergy medicine Sneeze Be Gone. The regular adult dose is 20 milligrams. As with all medicines, the body gradually filters Sneeze Be Gone out of the bloodstream. The rate at which the medicine is filtered out is called the flush rate. For Sneeze Be Gone, the flush rate is 30%. In other words, 24 hours after the pill is taken, 30% of Sneeze Be Gone has flushed out of the body. So how many percent left? If 30% of Sneeze Be Gone has flushed out of the body after 24 hours, then when you start with 100%, subtract 30%, you get 70% left. This is pretty straightforward, okay? So now question 2 in the content discussed, at what value does the amount of Sneeze Be Gone in the bloodstream level off? Meaning, at what time, at what amount, it doesn't keep increasing anymore, okay? And how many days does it take for that to happen? And that's when usually the medicine take effect on you. So use the calculator's recursive feature to create table. Assuming that an adult is taking one 20 milligram dose per day. So previous session, if you haven't watched the previous recording session, please go watch the recording session for scalar plot, recursive and explicit, linear and exponential function. I explained how to write recursive function and how to use it. But here, this is the recursive function for this scenario. Okay. My recursive functions is an equal to an minus 1. This means this is medicine from previous day, what's left from previous day. times 0.7 because it's 70% of medicine left in my blood, plus 20, which is 20 is the pill that I take the next day. And the first day I start with 20 milligram. Okay. So to calculate the value for each day, we can use the recursive calculator to calculate the value for each day. Okay. So day 1, there's 20 milligram of snispegon in your bloodstream because you just took it. And then after 24 hours, you will gradually have only 70% left. So the next day, you start with 20 times 0.7, okay? Because it's gonna only 70% left. But because you're taking a new pill, so you plus another 20. That's a new pill that you're taking. Then you have 34 milligram left in your bloodstream. And then on the third day, you start with 34 milligram. And same 34 milligram, 30% will be gone, so 70% will be left. And you are taking another pill, which is another 20 milligram. And that results with 43.8 milligram. So to use your TI-84 calculator, give me a second, let me pull it up. I can show you on the screen. Okay. Okay. So using this calculator, you start with turn it on, 20%. Hello. Okay, I turn it on. First day you start with 20 milligram, and the second day is 20 milligram times 0.7 and plus another 20 milligram for new pill. That's the second day. That's what's left. And then the next day, you will have the answer, previous answer. You click second, and then the minus sign, the negative sign, times 0.7 plus another 20 gram. Enter. Then you get the amount left for the next day. And then the next thing you got to do is click enter, and you calculate the next day for you because this is a built-in recursive function on the TI-84. And then you click again. So we have calculated. Let's calculate. See. Oh. So the first line we see here, this is the second day, third day, fourth day, fifth day, sixth day, sixth day, seventh day, eighth day, ninth, 10, 11. Then you see the medicine is leveling off. So you record this data in your table, okay, using this. Probably counted wrong, but once you click one, you will record it in a table. So keep going. You repeat until you have the answer labeled off, and you should get the data that you got from in the table that is shown in the content. All right. Now, about 18 days, you will see the medicine is, pretty level, about 66.6. Because after the 19th day, 20th day, that's what you're going to see, 66.6, even though you keep adding it. And that's when it's level off. And that's how you can tell when the medicine is level off. So in your assignments, it's asked, at what value does the amount of sneeze be gone in the bloodstream level off? Usually the second question, how many days does it take for that to happen? How many days? In this case, it's 18 days. But in your case, when you start with different amount of medicine, your formula does change some. And later on, we're going to talk about how does it change. Okay, what type of function could model the amount of sneeze be gone in the bloodstream as a function of time? This information also taken straight from the content. Since each day of the medication contains a rate of decay, okay, the medicine is slowly reducing. The behavior of the exponential function is expected. The patient, however, also takes a new pill daily. Every day you add a new amount, right? Which increases the amount of sneeze be gone in the bloodstream quickly all at once. In the morning when you take the pill, then the amount increases. So therefore, the discontinuous behavior is also expected, meaning the graph will break off. It's not going to be continuous. Which leads to a type of step function. Okay, here is a breakdown of the function. In the general form of exponential decay function is when the rate of decays is here. The rate of decays comes from what's left in the blood, how many percent is left. So in this case, we're talking about 70%. And you change the percent to decimal, you will get 0.7. Okay. So and the A is the starting amount of the substance. So continue with the previous questions. For 20 milligram dose, which is 20 milligram is when the dose that we start for that day, for the first day, and 30% flush rate, meaning 70% left in the bloodstream. What exponential function could describe the amount of sneeze be gone in the bloodstream? Y as a function of time. And do not forget, B represent the percent, okay, of sneeze be gone. This is B that remains in the bloodstream. And 70% remain in the bloodstream. So in this case, we got 20 to start with. This is starting amount. Okay, so in your assignments, they ask to, you start with different dosage. So your starting amount, this 20 will be different. You will have 30 or 40, whatever the question asks for. And 70%, because we are using the same kind of drug and the flush rate is the same, so you will have the same one. And the -1 in the exponent here means -1 means this is a function that apply for day 1, because you don't, on day 0 there's nothing is happening. Day 1, the first day when you take it, so you will shift the function -1 to, meaning it start with day 1. Okay. All right. Since the patient did not begin taking the medicine until day 1, so that's what we just talked about, adjust your function rule by subtracting 1 from the exponent. Graph the function on your graphing calculator. Sketch a graph and describe your viewing window. So this is what provided in the course content. Okay. We are going to try it on decimals. Desmo is a free online graphing calculator. You should try it out, and we're going to try it out. Click on this link and type this that I showed, and we will see what we will see. Let's look at the screen now. So here you're gonna type y equal to 20 times 0.7. Okay, and then use Shift 6, which is give you a little cap thing, and put a parenthesis x minus 1. Okay, and you should see this graph. And you can see using Desmos, you can change the color of the graph here. Okay, and that is what we see now. It's decaying, and later on we're going to look at how we put in a restriction of time. Okay, we're going to go back to our slide for now. Okay, so you should get the same thing. You can also scroll out to zoom out for this graph, just like how you use Google Map. All right, continue from question 3. If time of x is given in terms of the number of days, what happens to the amount of sneeze begun in a patient's bloodstream at the start of day 2 when the patient takes the second pill? So how does this affect the graphs? And we're going to talk about the amount by taking the new dose. It's a new dose of 20 milligram. This causes a vertical shift. So the graph, it was kind of low, and then it moved up because you have more out of sudden, 20 milligram more at day 2, suggesting the need of step function style graph. Okay, so these are all the keywords that I highlighted. So because this function right now only apply for day 1, because day 1 you start with 20 milligram. Okay, and then it's only apply for day 1. We're gonna try it on Desmos, and you're gonna type these, the same thing that you typed just now, 20 times 0.7 cap, and in parenthesis x minus 1 parenthesis, and at the back here, that's how you put in restriction between day 1 and day 2. The x representing days. Okay, x day 1 and day 2. So let's go look at it in a graph. So the graph that we were looking at just now, type the same thing. Okay, here's the same, except I'm going to put in a restriction. X is between 1 and 2, meaning this graph only apply for day 1 until day 2. Okay, and you can see it has only a section. Look at the scale of the x. Is each box has scale to 5, so each little one means it's 1 day. So this graph is only happening from day 1 until day 2, and because in the beginning of day 2 you are going to start with a new dose. 20 milligrams is going to add to it. So now go back to our slides. day 2, go to your decimal graph. You're gonna start with y equal to 34 times x times 0.7 to the parenthesis x minus 2 right here. What do the constants 34, 0.7, and 2 means? We talked about it previously. The first number here represents the starting values of the medicine. And for day 2, the function changes because the starting value changed. And because this function only apply at day 2, we need to have a minus 2 over here. However, the flush rate is the same, so we don't change the flush rate. Now, to graph the function for between day 2 to day 3, what the medicines left in your blood, go back to your decimal graph, and you will create a new function on the same page, which I'm going to show you, and this is what you're going to type. Okay. So let's do go back to our graph. Okay. So you click on the second line. That's how you start a new graph. You just type y equal to 34. You can do parentheses or you can do times 0.7 to the power of x minus 2. Again, minus 2 is because we're starting at day 2. And this function only applies between day 2 and day 3. So you have to put in the time restriction of 2. Sorry. Typo error. Day 3. And then enter. So now you see the graph is in blue. It's starting at day 2, okay, day 1, day 2, until day 3. So it still has the flush rate of 30%, and because of 0.7 it would put in, and it's starting at minus 2. This minus 2 allows you to, meaning the graph is shifted to the right 2, meaning also it's starting at day 2. And you can change the color of the graph if you want to. This is how you change it. Change it to green or purple. I'll just keep it blue. Okay, so that's day 2. Now, so just what we talked about, 34 means the amount of sneeze be gone in bloodstream at the beginning of day 2 after you took the new pill, and the percent of sneeze be gone remaining in the bloodstream after 24 hours, which is, after the subtract the flush rate, this is 0.7. And 2 is a horizontal shift in the domain for day 2. Alright. Right now, please click try it out on your own using the decimal calculator. This is what you're going to do. You're going to create a new function on the same page like I just did for the second function. But now it's day 3. What do you think 43.8 come from? And what do you think 50.7 comes from? And why is it minus 3? Why is it minus 4? Because it's day 3. So you got minus 3 because that's when the function start. And 43.8 is the amount of the medicine that they it started with after the patient took the pill. It's 43.8. And this function only applies between day 3 and day 4. Okay, and so on day 4, the function changes because the beginning amount of day 4 changes. And then you will have -4 here because that's where it starts, day 4. And then once you try it out, you can click here to see the completed graph with notes. I put it in the notes to explain why the graph is what it is. Okay, so once you created a graph, you will take a screenshot of the graph and then attach in a Word document. The assignments that you have alone is not enough space for you to put in all your answer in it. Okay, even though you use hand, you write it with hand. So it's a good idea to copy the questions to a new Word document and write your answer there, and also put your graphs using what you graded using Desmos in there too. So last questions. Assume the patient takes 20 milligrams of sneeze be gone every day. If you extend the graph by day 20 or beyond, what would the minimum amount of sneeze be gone in the bloodstream be? So we know, and in the assignment, so the idea of this after 20 days and beyond, you in the beginning we see the medicine stabilizes around 66.6 milligram, and so it will stay on that way because that's what the purpose is. It's gonna stay that way because that's what the patient needs. The patient needs around this milligram. That's why the doctors prescribe 20 milligram each day so that 66.6 milligrams stays in his blood. However, you can also calculate the maximum and minimum of the medicine left on that day, on each day. So assuming before the 66 milligram from yesterday being flushed, like yesterday you got 66.6, then you take a new pill, then you get 86.6, and the minimum is, after the 66.6 got flushed and you got 70% left, and then you add 20, then you have 66.6 milligram in the blood. So you got a maximum and a minimum. So for your assignments, like I just mentioned before, if you start with a different different dose, okay? If you start with different dose, then your starting amount will be different. Change the starting amount right here and follow the step that I showed above to complete your assignments. And if you still have questions, please don't hesitate to email me. And here's an additional resource to help you. If you need help for transformation of exponential function, this link will bring you to a video that explains all kinds of transformation. In the assignments, you do need to know when you change a certain value, what changes will happen to the graph. You can also just plug it into a graph decimal calculator and to see what changes. Change from 20 to 30, change any variables that you want. And this is a link of Decimal Online Free Calculator. It's free. You can create an account. You can link that to your Google account or any account. You can save the graph that you created. You can even submit a graph, the link of the graph in your assignments, and I will grade it from there. Make sure you save it. Otherwise, take a screenshot. How to take a screenshot? You can do a print screen using your keyboard and then attach to any image editor, a Paint or something. Save it JPEG, or if you have a snipping tool, snipping tool is the best thing I have. I use it every day. On the Windows has it. I'm not sure about Apple products. You do in your Windows Start button, you search snipping tools. You come up with these scissors, and then you just can take part of the screen using different kind of outline, and then you can that when you take part of the screen, that copies. Let me just show you. I copy the screen immediately, and then you can paste it on your screen. Okay. So let's say I want to take a picture of this graph that I just made. This graph is not complete, but you will take a picture of the completed one. You turn on your snipping tools, okay, snipping tool, and you click on New. Okay, it allows you to search snip using freeform. Freeform meaning you can do different shape, any shape that you want. That's freeform. Or you can do rectangular snip, or window snip, or full screen snip. I usually do rectangular snip that allows me to drag a good ratio. Make sure you include the x-axis and y-axis when you snip it. And here's a picture. You can even write on it. If you write something wrong, you can erase it. And then you can copy it, or you can save it as a JPEG. That allows you to attach it to your documents to submit as assignments. All right, that's a little quick tool share. And I appreciate you watching this whole video, and I hope that helped. Thank you for watching it. Let me know if you have any questions. Email me or page me. My email is located under teacher information on the right side of the course homepage.